Okay, YouTube, in my past few videos here, we've talked about what matrices are and how we represent them, as well as how we can use a matrix to represent a system of equations here. So for instance, if we were to represent this here as an augmented matrix here, we'd have 3, -2, 1, -1, 1, and 2, and then 1, -1, and -4 is our coefficient matrix. And then we could just drop the constants on the right. We'd have 15, -10, and 14. And this matrix here would just be a more streamlined way of representing this. So in the last couple of videos, we actually worked on putting this into row echelon form or reduced row echelon form so that we could find solution or solutions to the system, or whether or not it has solutions. But in this video, what we're going to do is we're going to focus on taking a calculator approach. And so there is actually a way to type this matrix into your calculator and have it go ahead and modify this using elementary row operations so that it is in either row echelon form or reduced row echelon form. So let's go and take a look at how we do this. So the first thing we're going to do is we're going to indicate that all the steps are listed over here, but I'm going to kind of take you through this here. Now my calculator is a little bit different than some TI calculators, but I have a matrix button here. This one here says press second and then your X inverse key or your X reciprocal key. So above my X reciprocal key it says finance. Above yours it might say finance, but on mine right here my matrix key is right here. And when you go in your matrix menu, there are three menus: the names menu, the math menu, and the edit menu. So if you want to call forth a matrix, you can see all these capital letters with brackets around them. These are the matrices right here if you want to use them. As far as math is concerned, we can see all of the things that we can do with matrices here in the middle menu, and then edit. Now the first place we're going to go is edit. So I'm going to go to edit, and you'll notice that I can scroll up and down here, but we want to edit matrix A. Now you may already have a matrix in here. Mine, just because it just wakes up and starts anew every time, is going to have this one by one. But the first thing it does is it asks you to put the order in. So our order here, of course, always goes rows, then columns. So I would say this has 3 rows and 4 columns. So let's start by saying that I have 3 rows. We're just going to hit 3 and then enter. Look what happens. I've already got 3 rows. And here it's popped over to my columns number. If I type in 4 and enter, now all of a sudden I've got a 3 by 4. And you can see that if I scroll to the right, you can kind of see that right there. Now at the bottom of the screen, the interesting thing is we're going to input the values from our matrix into our matrix from our system here. We're going to just type in, you notice this in the top left corner here, we're going to hit 3 and then enter, and then it just pops over to the next entry in this first row. So we say -2, we'll hit -2, I'll hit enter, and then I'll hit 1, enter, and then it's even going to go here, it's going to be 15 and enter. Now before I hit enter here, what I want you to notice is that this 15 is in our matrix here. It lies in the first row but is in the 4th column. So technically, if this were some matrix, say A, then we would say that 15 is the first row 4th column entry in A. So basically what I want to point on the calculator is down at the bottom here it says 1, 4, and what that's indicating is this is the entry in the first row 4th column, and it's 15. So you'll notice now that I've hit enter, it pops down to the second row. So we have second row 1st column. Let's go put these in. We say -1, enter, 1, enter, 2, enter, and -10, enter. And then our last row here would be 1, -1, -4, and then lastly 14. So we have our matrix in here. So now here's the most annoying feature of this. It automatically saves, and that's what this says over here. But when you want to use this matrix, you have to exit this menu when you're done. You cannot go back in your matrix menu and hope to use this matrix. So we have to actually hit quit. And quit is right behind mode. So when you look at this here, what we're going to do now is a couple things. I'm going to go back into my matrix menu. And I'm going to go under names. I'm going to hit A. You notice A says 3 by 4. When I hit A this time, here's our A bracket, and when I hit enter, you can see that I have my matrix here. So one thing to do is make sure that you have all your values right here. I never really do this, but I can check in this instance here that all my values are indeed matching what I have here. So from our matrix menu, I'm going to clear this out. From our matrix menu, what we're going to do is we're going to go over to math, and we're going to scroll down farther and farther and farther until we get to these two options right here, A and B. So now the first one says REF, and that certainly stands for row echelon form, and reduced row echelon form is the RREF, which is way more valuable than REF, but that's just my opinion. But the first thing we're going to do here is we're going to hit REF. We're going to say REF of what? Well, REF of matrix A. And so this matrix A, I'm going to go back in my matrix menu. I'm going to pull it out. I'm going to say REF of matrix A in parenthesis here. When I hit enter, you notice that I get some pretty big repeating decimals. And if I scroll to the right, I can see these values here. But one thing I'll tell you is that this looks pretty hideous with these repeating decimals. So one thing you want to learn instantly is this. Once you get your REF here, on a TI at least, if you go into your math menu, it'll say convert to fraction is the first option. And because we have rational decimal values, if I say take my answer and convert it to fractions, here's what I get. So in REF form, we have 1, x minus 2/3 y, and then we'd have plus 1/3 z equals 5. So plus 1/3 z is 5 is our first equation. Now, our second equation in this REF form here would be 0, 1, 7, and negative 15. So we have 0, 1, 7, and negative 15. And then last but not least, we have in this last row here, it looks like a 0, 0, 1, and negative 2. So we have a 1z is negative 2. So I want you to see the benefit to using a calculator here. It takes you as long as it does to type all this in and hit REF of that matrix A just to get something we could totally go solve. So now let's talk about the RREF of matrix A. And if we do the RREF of matrix A here, what we get is something that's much more valuable, as you heard me say. I'm going to click on my matrix menu. I'm going to go back over to math and down to RREF. But then I'm instantly going to hit RREF of matrix A. So we'll go back and get matrix A out. RREF of A is going to give us something that may have fractions on it still, but what you notice here is that I've got this 1's down the main diagonal and 0's elsewhere on the left, and I have 5, negative 1, and negative 2. So what I get is this 1, 0, 0, 0, 1, 0, 0, 0, 1, and then we had 5, 1, and negative 2, if I remember correctly here. 5, negative 1, and negative 2. So what this means is for our system, we have x is equal to 5, y is equal to negative 1, and z is equal to negative 2. And so before we piece out of this video, we're going to mention something here. We have 5, negative 1, and negative 2 is our ordered triple that is the solution pair, or solution triple here. But basically, what I want to mention is this. If you can already just look at this and tell me what x, y, and z are, there's no need to rewrite the system here. So this is our solution, and all we had to do was put in this matrix in an augmented form and RREF it, and we arrive at the solutions if they exist. Cheers.